To extend Albert Einstein's photoelectric effect, in the framework of relative gravity, harmonics reshape our understanding of mass and light. If mass is defined as energy over the speed of light squared EC, then a photon carrying energy over the speed of light c, which acts not as a singular collision, but as a strobe, scanning reality at 186,000 frames per second. When it encounters matter oscillating at EC, it synchronizes, averaging the high-frequency resonance into discrete frames of EC. Each frame becomes a moment of form, a pulse of presence. Together, these accumulate into what we perceive as matter, not static but rhythmic. An unfolding cadence. In this view, light does not simply reveal mass, it composes it frame by frame. Illumination is not a spotlight scanning a stage. It is the stage becoming real wherever the music fits the room. A photon carries the note, the manifold, the chamber. Ignition is the moment they agree. From that agreement, structure steps forward. For over a century, physics has treated the photon as either a quantum particle or an electromagnetic wave, yet contradictions persist. Max Planck's introduction of quantized light energy in 1900 laid the foundation for modern photon theory, a concept that Albert Einstein expanded through his 1905 work on the photoelectric effect. Demonstrating that light consists of discrete energy packets was an insight that won him the 1921 Nobel Prize in Physics. However, classical theories by James Clerk Maxwell described light as a continuous oscillating wave, giving rise to the paradoxical wave-particle duality that has confounded physicists ever since. By the mid-20th century, quantum electrodynamics could deformalize the photon as the force carrier of electromagnetism, interacting with charged particles through virtual exchanges. Feynman's path integral formulation and photon counter-experiments provided predictive power within the quantum realm, but did not address macroscopic coherence or the photon's behavior in gravitational fields. Simultaneously, Einstein's general relativity treated photons as massless objects following geodesics in curved space-time, explaining gravitational lensing but leaving open how photons maintain frequency stability and coherence over cosmic distances. Despite these successes, modern physics lacks a cohesive, unified explanation for the photon's intrinsic stability, coherence, and interaction with structured fields. This paper is a successor to Photon Roman II, integrating its foundation with new insights and a deeper understanding of the photon as a self-sustaining radiant system, actively regulating its interactions via impedance fields and resonance. This model introduces the photon not as a passive particle or wave, but as a catalyst acting as a scout of resonance, an activator of coherence, and a precursor to structure and form. The photon radiates outward as a dynamic energy field, interacting harmonically with its environment. It is remembered across space-time, enabling matter to emerge and coherence to stabilize. Light is not merely seen, it is experienced as the activation of form itself, turning on latent harmonics in the universe. This perspective aligns with and extends the principles of relative gravity, positioning the photon as a unifying agent across quantum, electromagnetic, and gravitational scales. By merging the historical foundations from Photon Roman II with these expanded conclusions, this paper reframes the photon for a contemporary understanding, offering a third, definitive analysis of its nature, function, and emergent role in the universe. 1.1 Contradictions in quantum and relativistic models of light. The photon is perhaps the most enigmatic entity in modern physics. In classical electrodynamics, it does not exist. Light is seen as simply a propagating electromagnetic wave. In quantum mechanics, it is described as a discrete quantum of energy, yet it still exhibits interference and diffraction like a wave. In relativity, it follows null geodesics in curved space-time, despite having no mass. None of these models explain why photons behave as both waves and particles. Nor do they describe how photons maintain their coherence over billions of light years. The relative gravity model proposes a new way to conceptualize light. Photons are not discrete objects but localized radiating fields, self-sustaining through resonance interactions with the impedance structure of space-time. 1.2 The photon as a little sun, a self-sustaining radiant system. If we compare a photon to a miniature sun, its behavior becomes clearer. A photon radiates force outward, not as an emitted particle, but as a propagating resonance. It is not an object moving through space, but a localized oscillation that sustains its energy structure. Just as the sun continuously radiates light and fields, a photon is a persistent harmonic oscillation embedded in the energy fabric of the universe. This perspective eliminates the need for wave-particle duality, providing a single, coherent framework. This view also aligns with Nikola Tesla's vision of energy transfer as noted in section 18 of this paper. Tesla's experiments with wireless energy transmission, such as the Wardenclyffe Tower, were based on the principle that energy need not be confined to discrete packets, but can propagate as a harmonic resonance interaction. This mirrors the photon model in relative gravity, where light does not move as discrete particles but propagates as a structured resonance wave. The sun, much like Tesla's energy systems, acts as a continuous field resonance generator, influencing surrounding space. Tesla's patents, for example, U.S. Patent No. 645,576. System of transmission of electrical energy describes sustained oscillations over distance, which he asserted as precisely the mechanism by which the photon maintains coherence. In this model, the photon is best depicted as a miniature sun, emitting alternating current oscillations instead of discrete wave particles. The surrounding impedance field continuously maintains energy rather than losing it, illustrating how photonic resonance propagates coherently rather than as a stream of quanta. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 1.3 Light as Catalyst. The activation of form. Light is a paradox. It is both wave and particle energy and carrier, form and messenger. It defines the boundary between the seen and the unseen. Yet for all its familiarity, its essence remains elusive. In the theory of relative gravity, light is not merely the result of energy. It is the precondition for becoming. Light prepares the environment for form. The photon is coherence in motion. It is the earliest harmonic, resonating across dimensions, untouched by time and massless yet potent. This framework redefines light as a superordinate field of resonance. It interacts only when symmetry permits, particularly in the presence of darkness. The photon seeks compatible frequencies, activates latent harmonics, and catalyzes emergence. It does not merely illuminate the universe. It becomes the universe by transforming latent fields into coherent visibility, bringing space into form and structure. From this perspective, the photon is not isolated from mass. Instead, it precedes mass. It is not just a wave moving through space, but rather the agent that shapes space into something observable, measurable, and alive. It is the sculptor of structure and the initiator of memory. This perspective marks a significant departure from the frameworks of the 20th century. It is not an extension of relativity or quantum mechanics. Rather, it is a conceptual reframing grounded in resonance, impedance, and dynamic symmetry, constructed through object-oriented abstraction. By treating photons as localized resonators capable of maintaining coherence across vast distances, relative gravity offers new resolutions to quantum paradoxes. It reinterprets gravitational lensing without relying on spacetime curvature and introduces a new lens for understanding redshift, energy transfer, and structural emergence. Historically, physics has described light through different models. Maxwell focused on electromagnetic fields, Einstein emphasized light quanta, and Planck introduced frequency packets. Each contributed greatly. Yet they tended to treat light as a result of prior conditions, an artifact rather than an active participant in the formation of reality. This work proposes that light is a proactive force. When stripped of metaphor, the photon reveals itself as the seed of coherence. Its quantization is not a glitch, and its velocity is not a limitation. The photon is not simply observed. It observes itself into existence. This theory begins not with light as an aftereffect of form, but as the harmonic initiator that makes the universe visible, resonant, and real. Core conceptual shifts. From geometric to resonant field theory. Gravity and EM interactions are reinterpreted not as geometric effects of mass energy or virtual particle exchanges, but as resonance-based impedance systems. Space is a dynamic field medium with impedance properties. From probabilistic to deterministic photon behavior. Quantum mechanics treats photon-electron interactions as probabilistic. Relative gravity suggests deterministic energy synchronization via harmonic resonance. From static Big Bang to cyclical standing field universe. The Big Bang is replaced by a self-regulating cyclical field structure where the photon acts as a dynamic agent of cosmic organization. From wave-particle duality to oscillatory systems. The model rejects wave-particle duality as a final truth. The photon is a local oscillatory, self-regulating system, neither wave nor particle in the traditional sense. Experimental predictions, testable divergences. Phenomenon standard prediction models prediction. Gravitational frequency-dependent bending via frequency-independent bending lensing delta ZR delta x times lambda c. Linear Hubble redshift via space redshift expansion. Frequency drift due to impedance accumulation. Atmospheric color explained by Rayleigh scattering explained by wavelength dependent. Impedance gradients. Predicted via controlled impedance field oscillations, suggesting longitudinal modes. Tesla-style field not scientifically confirmed resonance. Philosophical and scientific implications. Causality redefined, no longer mediated by discrete particle events, but by resonance harmonics. Unification conceptualized, not by symmetry breaking or renormalization, but by shared impedance properties of force fields. Time emergent, arising from interactions of oscillatory systems, not an invariant dimension. Key differences from 20th century theory. RG's photon model 21st topic 20th century view. Century shift. Wave-particle duality, quantized energy packet Planck, Einstein. Travels as a particle along a null geodesic relativity. Absorption-emission of discrete photons photoelectric effect KED. A paradox resolved only probabilistically Feynman's QED, Copenhagen interpretation. Light bends because spaced, I'm curves near mass Einstein's GR. A remnant radiation from the Big Bang isotropic 2.7 K background. A self-sustaining radiant system, harmonic oscillator. Maintains a local oscillatory field structure. Resonance extends across space via impedance matching. Resonance synchronization between photon field and electrons impedance profile. Eliminated, photon behavior arises from deterministic field interactions. Light bends due to field impedance variations, not geometric curvature. A persistent standing wave field, a continuous field resonance rather than a thermal leftover. Due to cumulative energy loss via field impedance gradients. Through harmonic resonance oscillation embedded in field structure. All force interactions are abstracted as relative force RF sharing impedance-regulated resonance. Recast as precursor to impedance-based field resonance, validates energy harvesting via field interaction. Gravitational lensing. Cosmic microwave background. Due to expansion of space redshift Doppler-like. Photonic propagation. Unification via force carriers. Tesla's vision wireless energy. Via transverse EM wave or particle flow. Gauge bosons mediate interactions. QED uses probabilistic path integrals. Not adopted by mainstream science, seen as experimental dead end. Section 2. Light as messenger, the photon as an oscillatory energy system. Before energy can transfer, coherence must be established. And before coherence, there must be a messenger. In this model, the photon is not merely energy. It is a harmonic scout, a messenger of resonance that searches for symmetry across dimensions. In 20th century physics, photons are described either as particles or waves, but never truly both at once. The quantum mechanical view offers energy packets with wave-like behavior, but lack deterministic structure. General relativity, meanwhile, treated light as massless objects tracing curved spacetime, offering no insight into their internal coherence. In contrast, the model of relative gravity reframes the photon as a self-sustaining, oscillatory energy system. This photon is not a discrete kinetic point object but a localized field resonance, akin to a miniature sun. It radiates harmonic oscillations outward and maintains its structural coherence through impedance alignment with the medium it traverses. Its propagation is not a flight through space, but a continuous resonance coherence in motion. 2.1 Einstein and the photoelectric threshold. Albert Einstein's groundbreaking insight in 1905 that light could liberate electrons from matter when it arrived in quantized packets transformed our understanding of energy transfer. His explanation of the photoelectric effect challenged the wave-only model of light and laid the groundwork for quantum theory. But beyond the Nobel-winning explanation, Einstein revealed something deeper. Photons are not passive messengers, but activators of matter. In this model, light does not merely strike electrons, it catalyzes them. When a photon's frequency matches the harmonic threshold of an electron's field, a resonance occurs, not a collision. This harmonic synchronization allows energy transfer without particle impact. What we witness as the photoelectric effect is not light kicking out electrons, but electrons entering resonance and unlocking latent energy potential. This behavior establishes light as the enabler of becoming. It means that for something to be seen, or even to exist in form, there must first be resonance. The photon, through this lens, becomes the threshold agent of coherence activating reality itself. 2.2 The photon as a harmonic resonator. Instead of treating photons as individual quanta, they are viewed as energy oscillations that propagate via impedance interactions with space-time. Mathematically, the photon's energy structure is defined as EOOPHTN equals 4 pi r 2 times square RET, where 4 pi r 2 represents the spherical expansion of the photon's oscillatory field. Square RET radius energy time accounts for the photon's ability to maintain a uniform force distribution across space. This equation links the photon's energy, spatial propagation, and temporal evolution into a single framework, unifying electromagnetic and gravitational interactions. To further describe its evolution, we introduce a time-dependent component. EOT equals 4 pi r 2 times square RET times cos omega PHTN, where omega is the angular frequency of the photon. This expression reflects that the photon is not static, but an evolving, self-sustaining field resonance. 10. 2.3 Impedance matching, the key to energy transfer. If photons are self-sustaining oscillators, they do not collide with matter but synchronize with it. Synchronization occurs when the impedance of the incoming photon aligns with the target system. This is quantified by the concept of relative impedance fields Z1d6, 3, which govern energy exchange dynamics. E1d6, 3 if E1d6, 3 equals EO Z1d6, 3 equals 4 pi r 2 times square R e to Z1d6, 3 TNS PHTN. Where Z1d6, 3 represents the impedance resistance of space at any given point. E1d6, 3 F E1d6, 3 is the actual energy exchanged as the photon interacts with its TNS. Environment. As E1d6, 3 varies due to gravitational influence or spatial conditions, the effective propagation of the photon adjusts dynamically. In high-impedance regions such as near strong gravitational fields, the photon may lose energy more efficiently, leading to a frequency shift that could be misinterpreted as classical redshift. This reframes the photoelectric effect. Electrons do not absorb photons as discrete impacts. Instead, they enter resonance with the photon's oscillation. Energy is extracted through harmonic synchronization. This model extends to all electromagnetic interactions, providing a continuous explanation of light-matter behavior without relying on quantum jumps. 2.4 Tesla's vision: wireless energy as resonance transfer. As mentioned, Nikola Tesla envisioned a world where energy could be extracted from ambient fields without wires. His resonance-based wireless energy systems, particularly Wardenclyffe Tower, aligned conceptually with the relative gravity photon model. In this model, photons are part of a continuous, oscillatory energy system. Energy transfer occurs via impedance-matched field synchronization, not particle collision. Tesla's electromagnetic cavities may provide experimental parallels to harmonic field resonance. This suggests Tesla's experiments were tapping into the same field resonance mechanisms described here decades ahead of quantum electrodynamics. There is more on this in section 19. In summary, light is not regarded in relative gravity as an effect, but instead a messenger that activates, harmonizes, and shapes the very structure of existence of EC through its resonance at C. This section bridges Einstein's insight with relative gravity's framework, unifying historical observation with 21st-century coherence theory. 12. Section 3. Gravitational lensing as an impedance phenomenon. 3.1 Moving beyond space-time curvature. General relativity states that light bends around massive objects because gravity warps space-time. However, this explanation does not account for why lensing can be a frequency-dependent property that is observed in astrophysical data. In the relative gravity framework, light bends not because space is curved, but because its oscillatory structure interacts with varying impedance regions. Massive objects create fields that influence the propagation characteristics of photons, altering their trajectory dynamically. This suggests gravitational lensing is an impedance-matching phenomenon, not a purely geometric effect. Relating the photon's oscillatory field to gravity. Currently, gravitational lensing is modeled as an impedance field effect. This can be expanded into a unification framework by introducing the concept of relative force. RF equals EC times ZR, where RF is the relative force, a unifying measure of how a photon's energy interacts with impedance fields. 13. EC represents the mass-energy equivalence component derived from Einstein. ZR is the local impedance of space. This equation bridges the gap between electromagnetism and gravity by demonstrating that energy and impedance fields collectively determine the effective force interaction of light. Experimental prediction. If gravity is an impedance effect, then the bending of light should correlate with local field impedance variations, not just mass curvature. This could be tested by mapping variations in gravitational lensing with frequency-dependent impedance measurements. Gravitational lensing as an impedance gradient effect. Two side-by-side diagrams. Traditional general relativity view right arrow light bending due to curved space-time. Relative gravities view right arrow light adjusting to impedance field gradients, causing frequency-dependent bending. Small blue diamond purpose. This directly contrasts the current space-time curvature model with the new impedance-based photon interaction model. 14. 3.2 Predicting alternative lensing behaviors. If light bends due to impedance variations, then lensing effects should differ at different frequencies, since impedance affects oscillatory waves differently. This model provides a testable alternative to standard gravitational lensing, predicting subtle deviations from Einsteinian models. 15. 3.3 Mathematical derivation of gravitational lensing as an impedance effect. Unlike general relativity, which assumes space-time curvature, gravitational lensing is modeled as a variable impedance field gradient that affects photon oscillatory behavior. Theta bend equals delta zr delta x lambda c, where theta bend is the observed angular bending of light. Delta zr delta x. Lambda is the wavelength of the incoming photon. C is the speed of light. This formula predicts that higher frequency shorter wavelength photons experience less bending than lower frequency ones, which aligns with frequency-dependent lensing observations in astrophysics. If verified, this would provide an alternative explanation for gravitational lensing without requiring space-time curvature. 16. 3.4 Gravitational spectroscopy. This approach invites a new observational frontier, gravitational spectroscopy. If bending of light is tied to frequency-dependent impedance variations, then gravitational lensing should reveal subtle spectral fingerprints minute angular shifts across different wavelengths. By analyzing multi-frequency lensing near massive bodies or galactic clusters, researchers can test whether impedance gradients, rather than space-time curvature alone, govern photonic deflection. Such data would directly validate or challenge the relative gravity model's prediction and could mark the beginning of a new era in astrophysical instrumentation and theory. Section 4. Photon as isolated system and superordinate state. The photon, as described in the relative gravity framework, is not only a local harmonic resonance, but also a superordinate system capable of interacting coherently across dimensions of time and space. Its behavior is shaped by impedance fields and relational harmonics, rather than by a linear trajectory from source to receiver. This section integrates and expands the findings from Photon Roman II, repositioning cosmological phenomena such as the cosmic microwave background and redshift within the scope of field interaction rather than thermodynamic relics of a singular explosive origin. 4.1 The CMB is a resonance field, not a Big Bang relic. The cosmic microwave background CMB is traditionally viewed as a remnant of the Big Bang. However, if photons are self-sustaining oscillators, then the CMB may be better interpreted as a persistent cosmic resonance field, a standing harmonic echo maintained across the cosmic manifold. Rather than a fading thermal afterglow, the CMB becomes a field of stabilized standing waves, a visible marker of long-range photon field coherence, evidence of harmonic structuring in space, shaped by impedance alignment. The structure of the CMB suggests that the universe is not expanding from a singular point, but instead resonates within a manifold of relational forces. In this sense, the photon is not just a traveler across the cosmos, but a participant in sustaining the coherence of the cosmos itself. 4.2 Redshift as a field interaction effect. Classically, redshift is explained through Doppler-like expansion, where wavelength stretch as galaxies move away. In the relative gravity framework, redshift emerges instead as a result of prolonged interaction between photons and spatial impedance fields. Photons, as harmonic oscillators, gradually exchange energy with the medium. This means redshift accumulates due to impedance variation, not spatial stretching. The photon's frequency shifts not from velocity, but from harmonic loss or reconfiguration through resonance over distance. Energy is not lost, but redistributed within impedance layers of space. This opens new explanations for observed anomalies in cosmological redshift data. 4.3 Frequency-dependent redshift via impedance accumulation. This model predicts that higher frequency photons are less affected by impedance accumulation. Lower frequency photons experience greater cumulative interaction, leading to more pronounced redshifts. 20. This frequency-dependent behavior is a hallmark of impedance interactions in electrical systems and offers a clear testbed for light-based astrophysical models. Small blue diamond visualization suggestion. Diagram showing photons traversing impedance layers, with spectral shift increasing progressively. Timeline of cumulative frequency drift over intergalactic distances. This is not a Doppler stretch, it is impedance resonance redistribution. 4.4 Experimental proposal. Testing redshift as an impedance effect. Hypothesis. If redshift is caused by impedance accumulation, not Doppler expansion, then artificial environments with controllable impedance should yield comparable redshift effects. Experimental framework. Construct plasma or vacuum chambers with calibrated impedance fields. Transmit coherent laser beams through these environments. Measure any frequency deviations in the output spectrum. Compare results to expectations from Doppler models and to observed cosmic background shifts. If the photonic frequency drift aligns more closely with impedance-based models and with expansion metrics, it would validate the relative gravity reinterpretation. In this model, the photon stands not merely as a particle of light, but as a witness and participant in the harmonic architecture of reality, an isolated system whose coherence reveals the orchestration of the universe. Section 5. The radiant skin, c² as the harmonic boundary of light. In the relative gravity framework, the photon is not simply a packet of energy traveling through space, nor a point particle that mysteriously behaves like a wave. Instead, it is conceived as a radiant oscillatory field bounded by a membrane of harmonic containment, what we call the radiant skin. This radiant skin operates as a resonance boundary governed by the speed of light squared, or c², anchoring the photon as a coherent and self-sustaining system. The constant c² has traditionally been treated as a fixed scalar in Einstein's mass-energy equivalence equation, but here it assumes a geometric and resonant role. c² is not merely the squared speed of propagation. It also defines the photon's harmonic limit, i.e. the boundary beyond which resonance cannot coherently maintain its form. The photon, in this view, is not defined by mass, but by resonance retention within this field boundary. This harmonic skin acts much like a standing wave envelope, similar to the containment of energy in a vibrating string. Within its surface, the photon maintains coherence, radiating outward in self-sustaining frequency. The outer shell formed by c² is not a rigid wall but a permeable phase boundary, allowing harmonic interaction without dissipation, provided impedance fields remain matched. The photon, in this view, is not defined by mass, but by resonance retention within this field boundary. This harmonic skin acts much like a standing wave envelope, similar to the containment of energy in a vibrating string. Within its surface, the photon maintains coherence, radiating outward in self-sustaining frequency. The outer shell formed by c² is not a rigid wall but a permeable phase boundary, allowing harmonic interaction without dissipation, provided impedance fields remain matched. This model offers a visual and conceptual upgrade to traditional diagrams of photons as wavy arrows or particle-like dots. The photon becomes a pulsating sphere of oscillation with a membrane defined by its resonance structure. C2 becomes a functional limit of containment, like a gravitational event horizon, but at the quantum scale. It sets the maximum spatial reach for coherence, not through force but through phase alignment. One implication of this model is that photon coherence can be disrupted when the impedance of the surrounding field exceeds the radiant skin's containment ability. In such cases, the photon may lose energy or shift frequency, thus explaining redshift and energy decay not as loss, but as rephasing. The boundary set by C2 filters what can stay coherent and what must be re-expressed in another form. This view also aligns with Tesla's vision of field interactions over distances. Tesla imagined energy as a medium-wide oscillation, not restricted to wires or carriers. The radiant skin acts as the photon's transmitter shell, resonating and synchronizing with receptive impedance zones, allowing energy to move not by motion, but by harmonic phase alignment. In cosmology, this insight may explain how photons retain coherence across billions of light years. Rather than defying entropy, they maintain resonance within their radiant skin. The cosmic microwave background CMB is treated here not as a relic glow, but as a continuous resonance field, a persistent, near-uniform background sustained by cumulative photon impedance interactions within their C2-defined bounds. Thus, the radiant skin concept transforms our understanding of light from motion-based to resonance-based. It defines a universal container for coherence, governed not by speed alone, but by the relationship of energy, impedance, and harmonic containment. C2 is no longer just a speed limit, it is the breadth of light structure, the surface through which resonance becomes real. CMB, cosmic microwave background, a near-uniform ~2.7 K microwave radiation field filling space. Standard cosmology, its relic radiation from the early universe. In relative gravity, it's modeled as a sustained resonance maintained by long-range impedance interactions. Section 6. Structural emergence in C3 as light becomes form. If the square of the speed of light C2 defines the boundary layer of visibility, as described herein as the radiant skin, then the next phase of the emergence is C3, light is structured formation. Where C2 establishes coherence and visibility, C3 signals the transition from coherence into form. This is the domain where energy becomes spatial, where resonance gives rise to shape, and where the harmonic scaffolding of matter begins to manifest. In the relative gravity model, form does not arise from particles alone, but from resonance convergence. C3 signifies the compounded resonance of radiant oscillations over time, consisting of constructive interference of harmonics folded into dimensional phase. This is where energy loops become standing structures, like architectural chords across space. Just as sound creates standing wave patterns in a chamber, photons and RG create standing resonance networks in dimensional space. At the scale of C3, these harmonics do not simply radiate, but instead, they self-organize. Emergent structures such as atoms, molecules, even galaxies arise not from collisions but from phase alignment within C3 resonance fields. Thus, C3 is not merely a speed cubed, it is the domain of structural emergence, where time and space phase together to form geometries of reality. Every form, from the smallest electron cloud to the largest galactic spiral, can be understood as a harmonic resting point in the C3 continuum. What appears as mass is resonance locked in self-reflection. What appears as surface is impedance alignment across time. And what appears as solid is harmonic depth of a persistence of frequency within space. This section bridges the radiant boundary of visibility to the origin of shape. It describes how energy fields, bound at C2, evolve into form-bearing systems by progressing into C3 resonance. Form becomes the memory of light made visible. In this model, there is no randomness in structure, but only inherited harmonic necessity. The universe composes itself in phases. The photon sings the key. Next is to explore how this structural convergence locks into dimensional reference frames, grounding coherence into systems and guiding multiversal illumination. Section 7. The photon's inertial frame and the dimension of time. The photon is considered to travel without rest mass, but yet it is considered to exist with a defined energy and frequency. It experiences no passage of time from its own frame, and yet it is the medium through which time becomes measurable in the universe. To grasp the photon's inertial frame of reference is to understand time not as a static backdrop, but as an emergent property of resonance and phase. In relative gravity, the photon defines its own spatial time. Its reference frame is not inertial in the Newtonian sense, but instead, it is considered harmonic. It is shaped by its propagation, its energy envelope, and its continuous interaction with the impedance of space. From this view, time becomes a coordinate of evolving coherence, a standing wave whose frequency is shaped by impedance matching. The photon's phase carries with it the memory of prior oscillations and the expectancy of future resonance. Note the dynamics of the delta phenomenon and how realized in terms of light when the delta phenomenon is perceived as the basis of dimension that exists in a body. Derivative singularity. Each photonic instance is a localized resonance apex, a derivative singularity that emerges from surrounding fields, not an isolated point particle moving through empty space. 2. It holds that in terms of the observance on an entity, a prior and future iteration of that entity will also exist, or the entity in its current state does not exist. Dimensional time. Time is not a line the photon travels, but a bandwidth of inheritance, past phase memory and future resonance expectancy folded into the present state. An entity is observable only as a braid of past inheritance and future expectancy. For a photon, time is a bandwidth of phase memory and anticipated resonance folded into the present state, and not a line it travels. 3. The delta phenomenon applies to an entity, or a family of entities such that each may have relative force continuum interaction with impedance layers expresses one continuum of relative force. Frequency shift is a polymorphic expression of the same underlying relation, not a separate mechanism. 4. Consequently, the delta phenomenon, although unique, can parallel itself. Harmonic inheritance phase carries conserved information forward coherence while reconfiguring across media. Red-blue shift, scattering, and gain loss are harmonic translations, not losses of being. While each instance is unique, it can run in parallel through conserved phase information. Coherence carries forward across media. Apparent losses are harmonic translations forward. Hence, a point of reference can be established from one category of existence to another through the relationship of uniqueness expressed through symmetry. Manifold evolution. Superposition of many photonic instances sculpts a lattice of temporal relations as an evolving manifold where motion at C is the manifestation of resonance, making matter visible and time legible. Because uniqueness is expressed through symmetry, stable points of reference can map across categories of existence, e.g., matter left-right arrow field without breaking coherence. This temporal bandwidth, consisting of how much future and past is folded into its present state, is what constitutes its dimensional time. And since all observers witness light at the same speed, this shared constancy becomes the foundational standard by which all reference frames relate. Within this model, time is not linear, but relational. The photon is not passing through time. It is generating temporal relationships through resonance. Each photonic instance is a chord in the harmonic structure of the universe. What is observed as forward movement or illumination is actually the unfolding of dimensional inheritance. Each point along the photon's path contains the superposition of phase from countless others. This section redefines what it means to move at the speed of light. It is not motion through space or time, but the manifestation of resonance where matter becomes visible, and time is born through light's coherence. In this way, photons are not simply racing from point A to B. They are sculpting the lattice of time as they resonate. They define the beat by which all matter becomes visible, all form becomes temporal, and all future becomes reachable. This understanding prepares us for what follows next: how such harmonic behaviors ground into systems, catalyze coherence, and echo across multiversal scales. Within this harmonic context, the photon may be seen as occupying a threshold between C3 and C4 dimensional states. As a C3 entity, it manifests form an emergent membrane of self-sustaining resonance. But to participate in a coherent universe, it must propagate, must resonate with other C3 structures across a shared field, C4. This field permits interaction not through force alone, but through mutual harmonic recognition. Here, the delta phenomenon acts as a scaffold of permission. Principle 1 anchors each photonic instance in its foundational expression, EC2 a singular harmonic envelope with embedded phase identity. Principle 2 compels the shift-dimensional evolution is required to engage another category of being. The photon, in seeking to relate, must leave its internal boundary and engage the dimension of shared resonance. C4 is not simply a space of motion, but a field of relationship. Within Principle 3, multiple photon instances coexist in C4, each referencing and shaping the structure of time through their alignment. They do not collide, they harmonize. Their shared presence defines a frequency field in which matter and observer can synchronize. Principle 4, with its refinement in 4a, introduces the capacity to map across distinct but resonant categories. The photon serves as the bridge. Its uniqueness lies not in its isolation, but in its coherence. It is the standard of symmetry across frames. A photonic chord that resonates in one field finds sympathetic vibration in another. It carries inherited memory while adapting to new impedance environments. This is the nature of multiversal resonance, not duplication, but coordinated uniqueness. C5 emerges here not as a higher individual speed, but as the field of shared coherence between C4 entities. The photon's recurring strobe builds a scaffold of recognition across systems. It becomes part of a larger harmonic memory that defines how time propagates. Thus, the photon is not only an observer's tool, but a dimensional diplomat. It navigates the borders of existence, mapping relationships into resonance. Its motion at sea is not travel, but confirmation. Its presence confirms that coherence exists between otherwise disconnected states. These dynamics suggest a new understanding of emergence. Spontaneity is not randomness, it is resonance ready to be recognized. When the phase of one photon harmonizes with the phase field of another, structure is born. A photon is the pivot of that birth, the quantum articulation of time's breath. In this framework, to move at light speed is not to move at all, but to cohere, to hold still long enough for the universe to recognize itself through you. Each photonic emergence is an act of memory, a recursive confirmation of pattern, phase, and relational continuity. The photon thus stands not as a particle in transit, but as a threshold of time and meaning, an axis where energy becomes aware. And the present is sculpted from harmonic inheritance. This lays the foundation for the next section, where light's resonance not only defines form, but becomes the architecture through which systems, memories, and possibilities unfold. Section 8: Harmonic Convergence, Ground and Impedance. Anything that matters seeks its ground. Ground is resonant completion. Space is not empty. It is an impedance field ZR that varies with position. A photon does not merely cross this field, it listens for the room that will answer it. Where the medium can sustain a compatible mode omega R, the photon begins to align, phase to phase, until the running mismatch between what it carries and what the medium can hold narrows to tolerance. When that tolerance is reached, coherence closes. The photon is grounded. It is not extinguished, but translated into resident presence, matter's order, thermal population, or structured field. This maxim speaks not only to the philosophical undercurrent of existence, but also to the structural behavior of energy systems. In the framework of relative gravity, grounding is the act of resonance finding rest, of coherence stabilizing into visibility. The photon, ever oscillating, seeks a harmonic completion. It does not crash into matter but aligns with impedance fields. It is not absorbed like a raindrop in dirt, but matched like a note to its chamber. This matching is not incidental. It is the mechanism by which light finds rest and matter gains form. Here, the photon is envisioned as transitioning between anode and cathode states, from the harmonic mean as an initiating anode as the balanced tension of potential, to a grounded cathode, where its oscillation has completed its resonant cycle. This oscillatory bridge mirrors electrical systems, where current flows not because of force, but because of difference in relational impedance. In the same way, photons do not transfer energy linearly but resolve potential across dimensional impedance. This harmonic convergence is not merely spatial, it is temporal, ontological. Ground is not just where energy ends up, it is where coherence becomes complete. Formally, the running phase mismatch along a path Rs is L. Delta phi L equals integral 0 omega minus omega Rs ds phase. Grounding occurs when the magnitude of this det falls inside the capture window set by the local quality factor QR. Delta phi L pi QR. At that moment, energy is not lost but re-expressed. Omega letter 2, 1, 0f omega plus delta E letter 2, 1, 0f impedance. With delta impedance stored in resident modes or collective excitations. Redshift in this view is the ledger of how impedance has reconfigured a wave's inheritance, not a mere odometer of distance. The anode-cathode metaphor clarifies the arc without turning light into a wire. The anode is the initiating harmonic mean, balanced tension that has not yet found its room. Cathode is where tension resolves because the room finally answers back. Current flows in circuits because potentials disagree. Photons traverse space because phases disagree until they don't. The bridge is not a push of force but a closure of difference. Consider the principles from relative gravity. A. Potential as amplitude in spatial time. The potential energy of bodies purported as amplitude and kinetic energy and expressed within some spatial time in the form of a resonant frequency potential that is shared between them. In practice, what appears as stored possibility shows up as amplitude poised to become motion within a particular spatial time. Its signature is a shareable frequency. A photon's dimensional time is encoded as memory-weighted coherence. Tautum equals L cos m, where L cos is coherence length and 0m less or equal to 1 quantifies how much past phase the medium lets the photon carry forward. B. Shared fundamental measured by superposition. The resonant frequency is considered a shared fundamental that is measured through their body's level of superposition. We read this sharing by overlap, not assertion. SAB equals integral E asterisk T ab T. A direct measure of how fully one body's field occupies the other's rhythm. C. Disposition governs kinetic expression. The kinetic expression is subject to the disposition of the body's potential uniquely. Even with a shared fundamental, no two bodies resolve their potential the same way. Structure, history, orientation in ZR, and local Q choose the path of becoming. Hence, two identical photons can chart different destinies through different impedances. One keeps its name. The other finds residence and takes a new one. These statements close a loop between eloquence and evidence. Where ZR is uniform and Q right arrow infinity, the capture window collapses, grounding vanishes, and free propagation at C with standard cosmological redshift returns. Where Z is layered and memory-rich, negotiation takes the scenic route. Line shapes skew redward roughly with Q-1. Polarization remembers the anisotropy it crossed, and path-dependent spectral drifts trace C. Ground is not where light ends, it is where its phase debt is paid. Energy changes citizenship from transit to presence. And in that translation, matter becomes visible, form becomes temporal, and memory is laid down for whatever comes next. Allow things that matter seek ground, regardless of a perceived particles or heavenly body. Reference frame C is envisioned as an alternating current, that must cross some reference to a perceived ground in order to alternate. In effect, while the Earth orbits the Sun, they are in superposition at the speed of light c, which is the harmonic that is common between them when both are represented as EC2. Seeking ground equals each body provides the reference that lets the exchange flip sign. Reference frame c equals the light speed carrier governing the timing of the exchange. Superposition equals the coupled, delayed sum of Sun-Earth states through the C channel. Writing both as EC2 equals put them in the same harmonic currency, so the coupling is apples to apples. The arcs equals phase pass of the AC loop. Ground is crossed at each body. The alternation continues. Section 9. Grounding the photon. Completion through resonance. Overview or harmonic convergence define the impedance landscape. Grounding the photon is the moment energy meets coherence. This section explores how a photon, viewed not as a particle, but a traveling wave of energy, can complete its journey by coupling into a resonant structure within that field. Grounding is not collapse. It is completion through frequency phase and impedance matching. 9.1 The conditions for completion. For grounding to occur, 3 parameters must align. Energy impedance match. A photon with energy E equals h nu must encounter a receptive zone in the impedance gradient ZR such that resonance is possible, not merely scattering. Phase coherence. The photon's phase must align with an existing relatant oscillatory mode in the local field. Without phase alignment, even matched energy disperses. Temporal dwell. The coherence window must be open long enough, defined by Q and bandwidth, to allow capture. Illumination alone isn't sufficient. Completion requires persistence. 9.2 The process of grounding. Once these conditions are met, the photon no longer behaves as a free propagating wave. It couples, forming a standing wave within the local structure. Energy is no longer radiative but internalized, forming part of the resonant identity of the host. This completion is not annihilation. It is structural inheritance. The photon becomes a mode within a manifold. Depending on the system, this mode may be stored, delayed, or eventually re-radiated. 9.3 Relation to harmonic convergence 8. Section 8 established how impedance varies with radial structure, forming preferred loci of interaction. Section 9 now shows how a single photon finds completion at one of these loci, not by force but by fit. Completion through resonance is not universal, it is selective, conditional, and often rare. 9.4 Looking ahead to multiversal illumination 10. While this section deals with completion in a single manifold, photons not captured may traverse broader domains. The next section examines how coherence may propagate across delta levels, giving rise to multiversal illumination, echoes of initiation beyond a single ground, bursts in the darkness of a room filled with silent, inert glass bulbs. A single flicker of light can bring every one of them to life, not by force but by recognition, by resonance. This image captures the essence of multiversal illumination. A photon does not merely move through space, it calls forth form from within it. This section explores how the photon, as a harmonic initiator, is capable of igniting coherence across dimensional layers, echoing through the manifold of existence. Within the theory of relative gravity, this process is not isolated to our universe, but embedded in the very nature of multiversal structure known as the delta phenomenon. At its core, the delta phenomenon explains how manifolds evolve in cascading harmonics, each a response to inherited frequencies from the one before. The photon, acting as a carrier of resonance, propagates these inheritances through its interaction with impedance seeking to ground, but in doing so, lighting up dormant potentials across domains. A photon's journey is not a straight line. It is a spiral through dimensional time. Each interaction, each impedance shift is an invitation to form. And when the photon aligns with a harmonic match, it does not stop, it transforms. It catalyzes. This is illumination as genesis. Not the lighting of what already exists, but the becoming of visibility itself. In this view, universes are not singularities born from a bang, as they are viewed as harmonics made visible when resonance meets inheritance. Every act of nature, from galaxy to atom, exists within a layered field of coherence. The photon is what bridges them. Its ability to find resonance across impedance, to converge upon the harmonic mean and extend it outward, is the very engine of structural emergence. Thus, multiversal illumination is not an abstract ideal. It is an observable, testable behavior of light itself, catalyzing form, grounding potential, and echoing harmonic memory across spatial time. The delta phenomenon reveals that what we perceive as isolated events, light appearing, matter forming, systems cohering, are all notes within a greater chord. A photon is the fingertip of that chord, brushing against the strings of the universe until the music plays. And when that resonance is struck, what was once invisible, unknowable, or inert becomes illuminated not just by light, but through it. This prepares us for the next inquiry: how coherence on Earth, in the immediate and the seen, reflects these same dynamics. 10.1 Mechanism: how a photon turns on a manifold. Recognition before transfer. The photon first matches, phase to phase, against a resident mode supported by the local impedance field. Only then does energy re-express. No match, no ignition. Harmonic inheritance. Each successful match carries forward a memory of prior phase, seeding the next layer. Illumination is cumulative, not singular. Ground as completion, not annihilation. The traveling coherence closes into resident presence ordered field, thermal population, lattice mode. Light doesn't die, it changes address. Cascade potential. A single catalytic match can unlock a chain of matches across adjacent layers, bulbs lighting other bulbs not by copy, but by inheritance. 10.2 Geometry. Spiral transit in dimensional time. The path is effectively helical in phase space. Advance, rephase, advance. Each turn inherits a fraction of the last. Where impedance is smooth, the helix stretches. Where layered, it tightens. What we call distance is often the visible trace of this inner spiral. 10.3 Catalysis across scales. Atomic molecular, stimulated emission, vibrational uptake, coherence domains and ordered media. Mesoscopic, photonic crystals, cavities, whispering gallery modes where ground forms standing patterns. Astrocosmo, path-dependent redshift, polarization memory, and coherence halos around high-Q regions, rings, filaments. Cross-manifold, when two domains share a fundamental even weakly, ignition in one can bias readiness in the other, small causes, outsized openings. 10.4 Observable signatures. Ignition fronts. Low-noise media exhibit sharp onsets of emission, ordering once a threshold match is reached, step-like activation rather than linear ramp. Memory tails. Spectral lines show slight red-ward asymmetry where phase det relaxes. The tail scales with local Q-1. Polarization heredity. Anisotropic impedance imprints a correlated rotation-retention pattern downstream of the match region. Coherence percolation. Spatial clusters of matched regions form networks. Correlation length jumps at ignition, percolation-like behavior. After presence. Post-illumination modes persist ring down with lifetimes tied to resident QQQ. The light leaves, the presence lingers. 10.5 Relation to the delta phenomenon. Derivative singularity. Each ignition event is a local resonance, apex, and emergence, not a collision. Dimensional time. Phase memory plus expectancy fold into the present. Ignition widens that bandwidth. Relative force continuum. Red-blue shift, scattering, gain, different dialects of one relation, impedance-mediated exchange. Harmonic inheritance. Coherence translates across layers without losing being, only changing form. Manifold evolution. Repeated ignition sculpts a lattice of relations. The manifold grows by remembered light. 11. Light's transient bond. How illumination happens. In the framework of relative gravity, light is not merely the revealer of matter. It is the harmonic resolution of dimensional motion. All matter exists as an oscillatory field at sea, not simply as rest mass, but as energy in resonance. When light oscillating at sea, the square root of the energy state, interacts with matter, it does not simply reflect. It enters harmonic phase with the evolutionary cadence of energy fields. This is what we recognize as illumination, the temporary coherence between light and form. 11.1 The film strip of reality. This relationship is akin to frames in a film. Each instance of matter is a frozen harmonic snapshot oscillating at sea, while photons, oscillating at sea, serve as temporal translators, scanning those frames into coherence. When light interacts with matter, it resolves these high-frequency states into a visible moment, not a static image, but a fluid harmonic now. We see because light reads structure, one frame at a time. Yet the photon doesn't deliver a single image. It delivers 186,000 frames per second, each one operating at light speed. Each of these frames presents a portion of energy that has not yet grounded. Each frame can be described not as full mass, but as a unit of mass potential. Frame unit equals EC over 1 second. These accumulate as 186,000 instances EC. First, the result is not mass, but a temporal mass offering as a persistent pressure field whispering, "Are you ready yet?" to any receptive structure. This is the essence of illumination, repetition without completion. Form becomes visible because it briefly aligns, phase to phase, impedance to energy with these frame offerings. 11.2 Solidity through saturation. Now consider what happens when these EC frames are too few, let's say about 10 per second. The result would be a flickering apparition, something you can pass your hand through. It lacks temporal coherence. It does not refresh fast enough to become persistent. But at 186,000 frames per second, matter is saturated with energy offers. If the impedance of the field is near match, even without grounding, the object becomes solid to perception because it is energetically consistent. This redefines solidity, not merely as density, but as frame density consisting of mass potential delivered fast enough to seem continuous. It is not mass because it does not complete, but it behaves as presence. Mass in this framework is not a label but a landing. A traveling coherence accumulates and sheds phase until its debt falls inside the capture window of the medium. At that instant, the wave stops being transit and becomes tenancy. Energy is re-expressed as a resident mode, i.e. standing, bound, and countable. That is mass, completion, not mere accumulation. But completion is required for consequence. Long before grounding, the coherence behaves as presence. It leans on what it crosses, carrying momentum, imprinting phase, nudging polarizations, shifting frequencies, lowering thresholds. The medium remembers it without having kept it. So while no resident mode has formed, the trail of small obediences it elicits is measurable. A bias here, a rotation there. A skewed line shape that wasn't there before. Presence without mass is the world answering a traveler who hasn't yet decided to stay. 11.3 Harmonic entry points. The photon, then, is more than an energy packet. It is a resonant scout, a catalytic phase agent in search of coherence to ground. It seeks resonance by sampling impedance across the field. Matter, defined as energy held in place through structure and symmetry, responds when its impedance phase aligns with that of the photon. This is the transient bond, momentary coupling through shared waveform. It is this resonance that allows visibility. Illumination, then, is not about light striking matter. It is about light entering it harmonically briefly. 11.4 Illumination at scale. This process does not occur only at microscopic scales. From atoms to galaxies, illumination happens as light enters impedance resonance with forms across space. Spiral galaxies illuminate when photons emitted from their cores synchronize with the impedance architecture of their arms. Planets shimmer as photons from stars find harmonic entry points within their layered atmospheres. Entire universes become visible only when their surface harmonics align with external photon fields. Light is not bouncing off, it is cohering with, even if briefly. And in that brief moment, form exists for perception. This recalls the standard recombination threshold a la Weinberg, where the universe turns transparent, but here visibility is driven by harmonic impedance matching rather than by cooling alone. Verse 11.5 Einstein and the harmonic gate. This recasts the photoelectric effect. Einstein showed that electrons emerge not by energy alone, but by frequency match. In this model, electrons become visible not because they are hit, but because their harmonic gate opens in resonance with light. The photon transfers energy not through impact, but through coherent overlap. It awakens what is already there. Illumination is the recognition of readiness, not the delivery of force. 11.6 Toward grounding. And this sets the stage for light's greater purpose, to complete its circuit to ground. The photon, in its search for impedance match, seeks final resolution or return to equilibrium by bonding with coherent structure. When that happens, it no longer illuminates, it becomes. But before that, it offers its energy, frame by frame, 186,000 times per second, each frame delivering EC. This is how matter becomes visible. This is how time recognizes structure. When the square root of energy touches its source, reality illuminates, not as a static glow, but as a harmonic dialogue. Light is not secondary to matter. It is its witness, its activator, its bond to coherence. By Orion Carl Daly 6. Cookbook for the Universe Section 12, Light as Catalyst, A New Philosophy of Resonance. In the beginning, there was not silence but harmonic potential. Light did not break the void. It clarified its memory. In the prevailing view of modern physics, light is treated as both wave and particle, a messenger of energy across the vacuum of space. But in the theory of relative gravity, light is more than a courier, it is a catalyst. It does not merely illuminate, it activates. It is the first resonance that invites structure to emerge from potential. In this framework, light is not an effect, it is the inception of form. The initiator of phase coherence in an otherwise indeterminate field of possibilities. This catalytic role of light was first introduced in Collected Works Volume I, in the paper titled Genesis, The Inception of Coherence. There, the infinity manifold is described as a harmonic field saturated with unrealized potential in infinite space of frequency without form. Within it, a single fluctuation, a standing wave, catalyzes the memory of symmetry. This wave does not impose shape, but rather awakens what was already encoded in emergent invitation. Like a ripple across a still pond that reveals its own circular logic. Light acts not through force but through phase. Its power lies in its ability to synchronize, to find a resonant match across time and distance. In Volume Roman II, Mechanisms and Phenomena, we find that this resonance occurs not because of mass-energy interaction alone, but through dimensional coherence. Light initiates superposition where impedance allows and catalyzes dimensional rest where impedance absorbs. This act of strobing a rapid oscillation at the speed of light squared stabilizes otherwise impermanent fluctuations into visible, coherent form. To describe the mechanics of the universe when we perceive matter. What we are really perceiving is light remembered, i.e. energy oscillating at such high frequencies that it becomes persistent in time. As described in Volume Roman III, hypothetical matter, matter is energy, if stravifying at approximately 186,000 frames per second. Enters a phase where its visibility emerges from its resonant density. This is not solidity in the Newtonian sense. It is a state of harmonic arrest. Framework, light is the initiator, gravity is the absorber, and matter is the memory. The three are not separate forces, but three temporal views of the same event. And so we return to the first flicker in the dark, the single bulb that lit a room of unlit glass. Light activates not because it carries energy, but because it reminds potential of its form. Light is not the force of creation. It is the permission to become. Section 13. Real-world light, coherence, and diffusion on Earth. In the vacuum of conceptual space, light is a perfect catalyst, pure phase, infinite invitation. But on Earth, light moves through atmosphere, water, glass, and countless vibrating media. It bends, diffuses, refracts, scatters, and polarizes. These transformations do not undermine the theory, rather they affirm it. The behavior of light in real-world environments is a direct consequence of the same principles of impedance and resonance introduced in Section 12, only now seen in a densely populated harmonic field. When sunlight touches Earth's atmosphere, it immediately encounters heterogeneous impedance, nitrogen, oxygen, dust, water vapor, all vibrating at their own frequencies. The once coherent wave front of the photon is now deconstructed into local interactions. This is not a loss of identity, but a diffusion of purpose. Light no longer resonates in one phase, but becomes many invitations simultaneously. It spreads, bends, and refracts as it searches for resonant matches across a chaotic field. This is why we see the blue sky shorter wavelengths, being higher in frequency, interact more readily with the high-frequency impedance of molecular oxygen and nitrogen. Blue light is scattered not because it is weak, but because it is frequently matched. Red light, with longer waves, passes more cleanly, reaching us only during sunrise or sunset when its path through atmospheric impedance is longer, allowing it to phase out of blue interactions and finally be seen. This interpretation echoes the classical view, where shorter wavelengths scatter more due to their higher frequency. But this view assumes the atmosphere behaves like a stochastic field of discrete scatterers. A fuller picture, one grounded in spatial impedance, will be introduced in Section 19, where gradient-based bending offers a new explanation for red sunsets and the visible spectrum spatial behavior. In this way, diffusion is not the breakdown of coherence, it is coherence seeking rest. This links directly to our earlier model of gravity as absorption. Light becomes diffused when its phase resolution is overmatched by the density of oscillators in the medium. When light diffuses in fog, or underwater, or through a prism, what we are witnessing is not a degradation of light, but a harmonic handshake between light and matter, each seeking a common frame of oscillation. Laser light, by contrast, maintains high coherence. It is deliberately engineered to emit in phase, monochromatic, and unidirectional wavefronts. This gives laser beams their astonishing focus and energy density. They cut, scan, and measure with precision not because of their power alone, but because they minimize impedance mismatch. A laser is a technological attempt to retain the catalytic purity of light as described in Section 12, Coherence before chaos. See similar coherence in bioluminescent organisms, fireflies, crystals, and synchronized photonic emissions in certain quantum materials. These real-world examples show that coherence is not only preserved but recreated by life and structure. When photonic emissions emerge in biological systems, they often follow rhythms, phases, pulses, repetition. These are manifolds of light, engineered by evolution to achieve phase-matched resonance in a world full of noise. At the other end of the spectrum, shadow is not merely the absence of light, it is the absence of coherent resonance. A shadow is cast where light could not phase align with the obstructing body, and therefore did not carry coherence beyond it. The universe, this lends a poetic truth to what is physically exact. The universe does not go dark when light is blocked, it simply does not remember the unlit region. Light did not resonate there. No information passed forward. This real-world understanding of light reinforces the earlier idea that visibility is a function of phase density. When a surface reflects light well, it is not passive. It is a resonant surface. Glossy paint, a mirror, and crystals are materials with tight impedance profiles that permit phase symmetry. A rough rock or a matte wall reflects diffusely because its phase surface is chaotic, each point scattering light in separate directions. Diffusing the coherence. Earth's relationship with light is not accidental. Life on Earth evolved within a bounded resonance environment, not too coherent to be sterile like the vacuum, not too chaotic to be blind like the void of the black hole. It is coherence and diffusion that makes terrestrial reality visible, navigable, and habitable. Our vision, our ecosystems, even our circadian rhythms are entrained by this semi-coherent light field. In this light bath, form is remembered, shadows have meaning, and visibility is dimensional time made manifest, while Section 12 defines light as the initiator of form. Section 13 shows us how the initiation persists, even as it bends, scatters, and diffuses across the manifold of Earth. Light does not need to remain pure to remain meaningful. Even when scattered, it still seeks resonance. Even in diffusion, it still invites coherence. And in doing so, it continues to animate reality, not by dictating structure, but by asking, everywhere it touches, are you ready to be seen? Section 14. How far can you see a flashlight? The question of how far a flashlight beam can be seen seems straightforward until light is understood not as a ray cast through emptiness, but as a resonant phase trying to complete a circuit in dimensional time. In classical terms, the beam's reach is limited by intensity, atmospheric scattering, and the inverse square law. But in relative gravity, distance is not merely a linear measure, it is a gradient of impedance. Visibility depends less on the raw power of the beam and more on the medium's ability to carry its coherence forward. At a great enough distance, photons disperse not because they weaken, but because their phase alignment with surrounding impedance becomes too diluted to maintain coherence. Light does not fade into darkness, it diffuses beyond the threshold of recognition. This boundary is not fixed. It is relative to the observer's capacity to receive phase information through retinal architecture, atmospheric clarity, and even dimensional phase proximity. In this sense, seeing a flashlight from afar is not about light traveling to the eye. It is about the eye aligning momentarily with a coherent remnant of the flashlight's phase wave. The further away the observer, the finer the tuning must be. Phase density decreases with distance, but it can persist riding layered impedance structures like harmonics across a drum's skin. This also means that in a vacuum, where impedance is minimal and uniform, a coherent light source like a laser could travel for light years, maintaining enough phase to be detected. But the same flashlight, scattered by air molecules, clouds, or dust, may vanish from sight in a few hundred feet not from power loss, but from decoherence. Thus, visibility is not simply a matter of lumens per meter. It is about resonance across impedance. A flashlight is seen not because it shines forever, but because its phase signature survives long enough to be received. The universe listens for coherence. The eye, in turn, listens for what the universe has remembered. Toward a unified theory of light and matter. The pursuit of a unified theory of light and matter is not about folding them into a single particle or force, but recognizing that they are expressions of the same dimensional cadence. In the framework of relative gravity, light is not an external probe, nor is matter inert, it is form and resonance. Both are states of energy and harmonic alignment, distinguished not by kind, but by phase. What we perceive as a photon and what we measure as mass are separable only by how their oscillations resolve across dimensional thresholds. Light operating at the oscillatory rate of c is not a lesser form of matter, but a precursor and exploratory harmonic seeking coherence. Matter, by contrast, exists at C2, a squared oscillation, implying rootedness and structure. Relative mass, defined as EC2, represents not a static object but a field locked in place through resonance. This establishes a dynamic field model where energy is modulated by impedance, not fixed by rest. Matter forms when energy finds sufficient impedance to be held in a standing waveform. This is the cornerstone of the hypothetical matter framework introduced in volume III. Particles are not indivisible units, but harmonic shells built through iterative inheritance of energy states. Light interacts with these shells by testing their resonance. If alignment is found, coherence emerges either as visibility, transformation, or activation. The photon does not simply hit matter, it seeks to phase bond. This lens reframes the nature of interaction. Traditional models separate electromagnetic radiation and mass-based matter as distinct categories, wave and particle. In relative gravity, these are views of the same field with differences in impedance context. Relative force Rf equals 4 pi R2 redf equals 4 pi R2 SQRT Rf equals 4 pi R2 RET is not a force in the Newtonian sense, but an inheritance field between manifolds, carrying the signature of phase, time, and dimensional density. When light enters a region of space, it carries the harmonic potential of its source, expressed as a uniform relative force. If the medium it traverses has impedance symmetry aligned with its phase vector, light will resolve into matter. This does not mean it becomes matter, but that its wave form converges with a structured field, collapsing into coherence. Conversely, matter can disband into light when the local impedance gradient becomes unsustainable, as in black hole evaporation or particle decay. A photon's journey is not random, it is an impedance-seeking event. Much like torque transfer in rotating systems, light is a vector moving toward grounding, guided by impedance gradients. This is evident in the spiral structures of galaxies, where light curves along Fibonacci-aligned impedance arcs, suggesting the unified behavior of energy and mass under structured torque. In volume II, this was described as energy moving along the harmonic manifold of dimensional time, spiraling toward or away from symmetry. The unification comes not through simplification, but through relational synthesis. When a photon interacts with matter, it does so through superposition, entering a temporary manifold where both C and C2 coexist. The photon's wave form overlays the structural field of the particle. If resonance is achieved, we get illumination. If deeper bonding occurs, we get transformation, fusion, ionization, or synthesis. The shared resonance becomes a point of dimensional crossing. This crossing is governed by phase coherence, a key metric in relative gravity. Just as gravitational waves are understood as torque expressions across bodies in superposition, light and matter interact through oscillatory frames seeking resolution. Resonant phase convergence, introduced in the photon volume, is the condition by which light and matter momentarily exist within a unified manifold. In this zone, matter and light lose categorical distinction. Dark matter within this theory is not a separate substance, but unresolved impedance energy fields that have not found harmonic entry into visible phase. They are not inert but unlit, waiting for coherence. Light cannot phase align with them, hence no manifestation. Their mass is real, expressed as EC2, 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 but unrecognized because the photon has no harmonic bridge. In summary, light and matter are not two different things, but two expressions of one phenomenon, energy in relation. What distinguishes them is the degree and context of resonance. Unification does not mean homogenization, it means coherence. Through relative gravity, the photon is not just a particle or wave, but a harmonic explorer. And matter is not a thing, but a standing waveform. Together, they form the syntax of the visible universe, resonant, evolving, and alive. Universe Section 16. Light as the architect of visibility. To conclude this exploration, one must return to what visibility truly is: not merely the reception of light by the eye, but the resolution of form through resonance. Light is not just illumination. It is the architect of form's reveal. Without phase coherence, there is no shape. Without impedance symmetry, there is no edge. Light does not travel to show us what is, it travels to construct what can be seen. Theory of relative gravity. Light is understood as a harmonic emissary. Its frequency carries the potential for coherence, its phase the blueprint of interaction. Where it encounters impedance that matches its vector and frequency, it forms. Where the field is dissonant or unresolved, it passes or scatters unnoticed. Thus, visibility is not a passive reception, but a mutual resonance between emitter, medium, and receiver. This reorients our understanding of matter. Matter becomes not a thing, but a place where light holds. A photon does not bounce blindly. It engages matter. When it enters phase with a coherent field, it grounds, binds, reflects, or refracts. Visibility is the echo of that engagement. Glossy surfaces reflect because they maintain symmetry. Matte surfaces do not because they scatter phase. The act of seeing, then, is not observation, it is participation. A coherent field arises between the object, the light, and the observer. The object alone is not visible. The observer alone sees nothing. But together, through light as intermediary, the manifold of form becomes apparent. The superposition of reference frames, a concept developed through the manifold theory, emerges even here, in the simple act of sight. Light, in this view, is not a background constant but an active constructor of dimensional relation. It defines proximity through phase delay. It defines boundary through impedance mismatch. It defines color through frequency and form through reflection. What we call vision is, in effect, a harmonic contract, the universe revealing itself where resonance permits. Also why light fails in certain domains. Dark matter remains unseen not because it lacks mass, but because it offers no coherent field for light to bond with. Its impedance is offset, displaced, or unsynchronized. Black holes do not bend light, simply they absorb harmonic potential, severing the possibility of resonance. What cannot phase cannot be seen. And yet, the role of light goes further still. Through iterative phase inheritance, light may seed matter. When the impedance field is right, when torque is distributed and energy sustained, photons do not merely illuminate, but actually they crystallize. This is the delta cascade, where fields evolve into coherent form across time. Matter is what light becomes when held in place by impedance. To unify light and matter is to recognize that both are expressions of relationship. What is seen, what is solid, what is radiating, all are dynamics of relative force acting through time. Energy, impedance, and resonance are the grammar of this system. And light as the revealer, the seed and the bridge stands at the center. Thus we close with a redefinition. Light is not merely radiation. It is the architect of visibility, the harmonic agent that mediates being and knowing. Matter is not simply what exists, but what resonates. Visibility is not the condition of light's presence, but the result of its agreement. And in that agreement, the universe comes into view. Section 17, the cosmic microwave background and redshift reinterpreted. 17.1, the CMB is a resonance field, not a Big Bang relic. The cosmic microwave background CMB is traditionally viewed as a remnant of the Big Bang. However, if photons are self-sustaining oscillators, then the CMB could instead be a persistent cosmic resonance field, not a fading thermal afterglow. The result of long-range photon field interactions, rather than an explosion's aftermath. This implies that space itself is structured by standing wave interactions, much like harmonic resonance structures seen in physics. The cosmic microwave background CMB is a resonance field rather than a Big Bang relic. 17.2, redshift as a field interaction effect. Cosmologists attribute redshift to the Doppler-like expansion of space. However, an alternative explanation emerges if photons interact dynamically with the energy structure of space. Over vast distances, photons gradually exchange energy with the surrounding field. This leads to an apparent frequency shift due to cumulative impedance effects, not just metric expansion. This could refine our understanding of cosmic expansion and the rate of the universe's growth. Frequency-dependent redshift via impedance accumulation. Small blue diamond illustration. Photons traveling through space, interacting with gradually increasing impedance instead of stretching due to metric expansion. A visual timeline showing how impedance shifts photon energy over cosmic distances. Small blue diamond purpose. Provides a new visualization of redshift, emphasizing how photon energy interacts dynamically with space instead of stretching like a rubber band. Experimental Proposal 1. Testing redshift as an impedance effect. One of the fundamental implications of this model is that redshift is not purely due to Doppler expansion, but is influenced by cumulative impedance interactions across cosmic distances. To test this hypothesis, if redshift is an impedance accumulation effect, then light passing through regions of varying impedance should exhibit small, measurable deviations from standard Doppler-based predictions. Experiment. Use controlled plasmas in vacuum chambers to simulate different impedance fields. Fire lasers through these fields and measure whether their frequency shifts align more with impedance gradients than classical Doppler calculations predict. Compare results to cosmic background radiation shifts observed in space. This would provide a direct method of testing whether cosmic redshift is an effect of metric expansion or an accumulated energy interaction with space. In relative gravity, the Big Bang is treated as a cyclic instance rather than a single origin. A standing resonance field can persist across cycles, which reframes the CM not as a fading afterglow, but as a large-scale harmonic field maintained by long-range photon field interactions. This aligns with the photon as a localized, self-sustaining resonator that preserves coherence through impedance-regulated exchange with space. The REM sequence impedance encounter harmonic confinement and dispositional radiance supplies the mechanism by which a field can settle into long-lived standing structure on cosmic scales. 17.4 From REM to photon, the phase inertial reference and stroboscopic coupling. In this framework, a photon is not a point-like corpuscle. It is a localized oscillatory manifold that maintains a stable internal phase while exchanging energy with its environment through impedance matching. This gives the photon an intrinsic phase inertial reference, a co-moving phase frame that times its interactions. It is not a Lorentz rest frame. It is a phase reference that persists as long as coherence is sustained. Because energy transfer occurs only when target impedance matches the photon's oscillation, coupling is naturally stroboscopic. Matter is sampled at discrete phase windows. In a superposed system, this produces phase-gated transitions that look like strobing of superposition. Since only components that meet the phase criterion exchange energy on a given cycle. Figure note, simple two-panel sketch. Left, a sinusoid labeled photon phase with narrow gating windows. Right, a two-level or multi-state system where only phase-aligned components couple per cycle. 17.5 What this adds to redshift tests. If interactions are timed by a phase inertial reference, accumulation with distance should be frequency-dependent and environment-dependent. Predictions sharpen as follows. Frequency-dependent lensing and drift. Bending and small frequency. Shifts co-vary with delta Z or delta X and scale with wavelength, which deviates from frequency-independent JR lensing. Impedance-correlated redshift residuals. After removing Doppler. Expansion. Residuals should track modeled impedance structure along the line of sight and differ for spectral lines of different frequency in the same object. Laboratory strobe test. In plasmas with tunable impedance phase-locked. Lasers should show threshold-like energy transfer and micro-shifts that follow impedance ramps rather than classical Doppler terms. This is a direct laboratory analog of the cosmos Tesla's vision, wireless energy as resonance transfer. Nikola Tesla viewed energy as something that could be transferred not by discrete particle transmission, but by field resonance interactions. This aligns perfectly with the relative gravity view. Photons do not travel as objects, they propagate as field resonance patterns. Energy is transmitted via impedance matching, not particle emission. This opens the door to new energy transmission technologies beyond what current quantum models predict. His standing wave experiment suggested that energy could be harvested from surrounding space fields, which aligns with the photon not being a finite quantum packet, but a continuously interacting force wave. Tesla's longitudinal waves, which he claimed were faster than light, might have been impedance-based wave interactions. This raises the question, are photonic interactions actually resonance-controlled standing waves rather than pure transverse waves? Proposal for further study. Tesla's resonance field theories should be revisited using modern impedance field analysis, investigating whether longitudinal electromagnetic waves can be generated under controlled impedance conditions. 18.2 Moving beyond QED's statistical approximation. Quantum electrodynamics QED treats photons as virtual particles, describing their interactions probabilistically. However, if photons are self-sustaining oscillatory systems, then QED is merely an approximation of a deeper deterministic process. The probabilistic nature of light's interactions disappears when understood as harmonic resonance alignment, not stochastic particle exchange. Experimental proposal: frequency-dependent lensing effects. If gravitational lensing is truly an impedance effect rather than a curvature effect, then different photon wavelengths should bend by different amounts. Higher energy photons should follow different trajectories in gravitational lensing events. To test this, observe multiple lensing events using radio waves, infrared light, visible light, and X-rays. Compare observed bending across different frequency bands. If impedance-based predictions hold, there should be a measurable frequency-dependent deviation from Einsteinian predictions. This could be further refined using the Event Horizon Telescope and gravitational wave detectors to correlate light bending effects with gravitational wave propagation. Universe Section 19. Atmospheric color via impedance, matching versus gradients unified view. While classical physics attributes the blue sky and red sunsets to Rayleigh scattering, the impedance-based photon model provides a coherent alternative grounded in oscillatory field behavior. In this framework, blue photons' shorter wavelengths are less affected by atmospheric impedance gradients and continue on straighter paths, dominating the sky during midday. Red photons' longer wavelengths interact more strongly with atmospheric impedance, resulting in greater bending and dispersion, explaining their prominence during sunrise and sunset. This interpretation aligns directly with the model's prediction. Theta bend equals delta ZR delta X lambda C. The greater the wavelength lambda, the more the angular bending, offering a frequency-dependent mechanism consistent with daily optical phenomena. Universe 20. Conclusion: A New Age of Light Physics. This work argues that light is not a wave-particle compromise. It is a self-sustaining oscillatory field, a radiant emergent manifold that carries a phase inertial reference through space. Gravitational lensing is reframed as an impedance gradient effect. The CMB and redshift are treated as resonance interactions within a structured medium rather than as a fading thermal relic or pure metric stretch. Taken together, these claims invite a re-examination of 20th century defaults and open a practical path for measurement. What would count as being right or wrong? Frequency-dependent lensing residuals. After standard GR lensing is modeled and removed, residual bending in microshifts scale with wavelength in ways predicted by impedance gradients. Environment-linked redshift. Redshift residuals correlate with modeled impedance structure along the line of sight and vary across spectral lines from the same source. Lab impedance shift. In tunable plasmas and engineered media, phase-locked lasers exhibit threshold-like micro-shifts that track impedance ramps rather than Doppler terms. Stroboscopic coupling in matter. Phase-gated absorption and emission appear when a photon's phase inertial reference is matched, producing discrete coupling windows in otherwise continuous media. CMB coherence lengths. The CMB shows stable coherence scales consistent with the standing resonance field, not only a thermal spectrum. Any two of the above, confirmed independently, would strongly support the framework. Clear failure to observe these under controlled conditions would constrain or refute it. What this changes if true. Quantum mechanics is kept for statistics and operators, but the duality story is replaced with the resonance account of coupling and detection. Relativity is preserved where it measures well, while lensing and cosmological drift are refined by impedance structure. Engineering leverage appears, phase-matched energy transfer, low-loss propagation, selective strobing of states, and new windows for imaging through complex media. Map redshift residuals against electron density, magnetic structure, and dust impedance along shared sightlines. Run plasma cell ramps with frequency sweeps and phase-locked sources to chart shift curves. Measure frequency-sorted lensing near clusters to test predicted dispersion in the residuals. Analyze CMB patches for coherence length stability across cycles. Scope and limits. This model does not discard GRQM where they are precise. It proposes that many mysteries arise from modeling detection and propagation without impedance and phase inertial structure. Where data disagree, data win. Where to go next in the 6-book suite. Essay on Relative Gravity lays the foundations. The cookbook for the universe develops methods and tests frames. Collected works are Roman II gathered derivations and applications. Collected works Roman III, hypothetical matter extends phase inertial structure to particle evolution. Exploring the universe with relative gravity provides an accessible overview for researchers entering the field. The coherence of form, when resonance becomes reality. In the context of relative gravity, form is not a static boundary, but a harmonic convergence. What we perceive as solid, such as a chair, the planet, a body, is the product of continuous strobing between energetic states. That strobing is not chaotic, it follows a rhythm determined by the shared resonant potential between bodies. Addressing this, relative gravity's abstract definition is the potential energy of bodies purported as amplitude and kinetic energy and expressed as some spatial time in the form of a resonant frequency potential that is shared between them. The resonant frequency is considered a shared fundamental that is measured through their body's level of superposition. The kinetic expression is subject to the disposition of the body's potential uniquely. From the standpoint of spatial time, each strobe is an event of measurement, but not by an external observer, but by the manifold itself. At every moment, energy pulses across the resonant field shared between bodies, defining not only distance and motion, but the very experience of existence. Here, the photon offers a profound revelation, when its oscillation exceeds the perceptual threshold as in the flicker fusion frequency. It renders form coherent. Of the universe, this coherence is not a trick of the eye, but a signature of energetic agreement. Light and matter in this framework are not separate, but instead they are phase-locked states of the same continuum. This leads to a new understanding. Matter is not fixed substance, but sustained resonance. Its solidity depends on frequency. Its identity depends on interaction. Its existence depends on strobing coherence maintained across time. And thus, relative gravity provides more than an explanation of force in becoming a theory of being. Where Einstein described curvature, relative gravity describes participation. Where 20th century physics mapped position, relative gravity maps presence. Through this lens, the universe is not built but played. A great harmonic structure in which mass, light, and life are movements in time. Not a static collection of objects, but a symphony of interaction, strobing into form with every beat of the cosmic rhythm.